Okay, hello all. Hope I'm audible. So let us proceed towards today's class. Okay, so this is the cutoff for the previous ATC examination. Just go through it. Let me check whether everyone has joined or not. Okay, everyone. So let us not waste any more time. Let us proceed onwards to this class. So today we are going to discuss about the topic called inverse trigonometric functions. Okay, inverse trigonometric functions. So I'm just using my mouse, guys. So I'm just apologizing for the delay. Okay. So what are those inverse trigonometric functions? They are the sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. Let's say we have y is equal to sine x. So we know that this is a function, right? So what does y represent? It's a value, right? So here y is the value. In sine x, what does x stands for? It's an angle, right? So here x is the angle. Same goes for, we need to find the inverse of this. That is, we need to find the inverse of this particular function. The inverse of this particular function is given by x. This is equal to sine inverse y. Okay. So in the chapter relations and functions, we have learned different types of functions, etc. Some can be 1, 1. Some can be onto. Some advanced functions like many one, bijective, subjective, injective, etc. Okay. So inverse is also a type of function. Now we need to know the principal value of all these functions. Of all these trigonometric functions, we need to know the principal value, because in questions we need to know its corresponding domain value to solve it. Okay, so I'll just show with the detailed diagram on what the principal value for each of the trigonometric functions. Okay, let us start. So let me give a heading called principal value. You guys can write out these notes. These are just short formula concepts. Okay, with these concepts you can solve any type of questions. Principal value. Okay, so first of all, let me show the principal value of diagram of y is equal to sin x. Okay, the figure will be like this. Okay, let me draw a wave. A wave will be coming. So it's getting deleted. Okay, okay. So here, this point is called amplitude. Let's say this is 1, and this is the negative amplitude, which is -1. Okay, so this is the corresponding angle value, which will be what? Pi by 2. Okay, that is sine at sine 0, sine 0 is 0, then it rises to 1 at pi by 2, right? So I'll just show the domain values and range values for each of the trigonometric functions, because if I proceed to drawing the diagrams, it will take a lot of time. Just know about sine inverse x, because for exams, for most of the questions, if you know sine inverse x, you can solve the others. But I will show in detail what are the domain and range values for sine inverse x to cosec inverse x. Okay, for sine inverse x, the domain is given by d is equal to closed interval -1, 1, and range are equal to closed interval where we get -1 at minus pi by 2, right? Here if we get -1, but it is at a particular angle, that is minus pi by 2. Here if we draw like this, we'll get -1 to 1, -1 to 1 at the angles minus pi by 2 to pi by 2. Okay, so it will be minus pi by 2 to pi by 2. So this is how we get the domain and range, but it's better that we just by heart it. Okay, for exam it's very difficult for us to draw these things and just understand it. Okay, and one more thing you need to know, that sine inverse x is not equal to 1 by sin x, because 1 by sin x is basically sin x the whole raised to -1. Okay, so these are, it's not equal, that's what I'm saying. Okay, so let me just write some basic formulas, like sine inverse of sine theta equal to theta. Same goes for x as well. Okay, that is sine inverse of sine x is equal to x. So for those who have already studied the chapter inverse trigonometric functions and are just here for revision, you can switch to a playback speed of 1.5x and watch it, so that it will be a revision for you guys. Okay. Okay. Now let me write some basic formulas, like for sine inverse x. Sine inverse x is equal to cosec inverse of 1 by x. Okay. Sometimes in questions it will ask like this: sine inverse of 2, sine inverse of 1.5, like that. At that time we don't have a value, that is, it's not defined. Not defined. Okay. Okay. So before here I have showed you why we need to know, like, domain of sine inverse x. Sometimes in a question may be asked like this. Show you. Question can be asked like, find the domain of y is equal to sine inverse 1 minus x. Okay. With the help of the domain of sine inverse x, we can solve this problem. Okay. We know that the domain of sine inverse x is -1, 1, right? So we can put it in a inequality form. Okay. That is -1 less than or equal to. I'm sorry for my handwriting because I'm just using my mouse as of now. Okay. So 1 minus x less than or equal to 1. Okay. I need to find here x. Okay. What can we do? We can just negate 1 from all these. That is, -1 minus 1 will be -2, less than or equal to -1 plus 1, 0. That is minus x, less than or equal to -1 plus 1, 0. Right. So we need to negate this negative. Give a negative multiplication throughout. That is 2 less than or equal to x less than or equal to 0. Here, so in this question, what will be the domain? X belongs to closed interval 0, 2. So this will be the answer for this question. Okay, it's a simple question. I think it has been asked in 2018 paper. That's why I just told you how important is that domain of sine inverse x. Okay. So some people might be confused, like what is this closed interval greater than or equal to, like that, something like that, right? So that is basically linear inequalities. That chapter is also important for AATC. If possible, if I have time, I will explain that chapter also. Okay, so let me just give a small introduction for this open interval and closed interval. Okay, open, closed. Okay, so open interval will be, the symbols will be like this: greater than or less than. Okay, for closed interval it will be like this: greater than or equal to or less than or equal to. Okay, secondly, we can represent in open interval for two variables a and b as like this: a less than x less than b. For closed interval will be like this: a less than or equal to x less than or equal to b. Okay, it's represented as a comma b open interval, or in some JE textbooks we can see like this: a comma b, but I better recommend to study this one. Okay, for closed intervals like this: a comma b. Then we need to plot this on the number line. It's quite simple. Okay, minus infinity to infinity, we have two numbers called a and b. Okay, so if we want to plot the open interval, we just have to give, no, it should not, we should not shade it. Okay, I just shaded that, make it like this visible, and draw this shaded area. Okay, for closed interval it will be like this: minus infinity to infinity, a to b. We have to dark the circle and we have to draw this. Okay, now let us move on to knowing the domain and range for each of the trigonometric functions. Okay, let's start with sine inverse x. Sine inverse x I have already shown, but still I'm going to write it. Domain and range. Just go through this. Okay, so firstly we need to know about sine inverse x. Okay, so first The domain is closed interval minus 1 comma 1, and the range is closed interval minus pi by 2 comma pi by 2. Okay. Second one is cos inverse x. Cos inverse x. The domain is same, minus 1 comma 1, but the range is different. Range will be closed interval 0 comma pi. Third one, tan inverse x. For tan inverse x, the domain will be all real numbers, and the range will be open interval minus pi by 2 to pi by 2. Fourth one, cot inverse x. We know that cot is the reciprocal of tan, so the domain will be real. And the range will be slightly different, that is open interval 0 comma pi. If a range is very hard for you to learn, just know the domain, okay? Because from most of my experience, when I went through the questions, based on the domain they're asking only, okay? So fifth one is sec inverse x. So for sec inverse x, domain is slightly complicated, but it's quite easy. Domain will start from, I'll just do a shortcut for how to find the domain of sec inverse x. Just assume that you have a number line diagram like this, okay? It starts from minus infinity to infinity. We have one turning point called 1, okay? It will start from here, it will go from here, plus, plus. The logic is nothing. It will go from, no, there's a mistake, sorry for that. Assume there are two turning points to find sec inverse x, okay? Print out the diagram, okay? From here to here, minus infinity to infinity. We have two turning points, one is minus 1 and one other is 1. That is, it will be like this. Come here, jump here, plus, plus. Just take a union of this where this plus is lying. That is, always infinity, for infinity it will always be open interval because it's keeping on going, it's not stopping. There is no closure for that, okay? So it will be like this, minus infinity comma minus 1 closed inverse. This is called semi-open and closed. Minus 1, infinity comma minus 1, semi-open because it's open first. Union, this is semi-closed, 1 comma infinity. This will be the domain. And the range is closed in an interval 0 comma pi. This is same as like cos inverse x, right? For cos inverse x, sec inverse x, it's reciprocal, right? Minus set pi by 2. Why I gave minus pi by 2? We know that cos 90 is 0, right? So 1 by 0 is infinity. So we can't include this particular angle. That's why we gave like this, 0 comma pi minus set pi by 2. Okay. The last one is cosec inverse x. For cosec inverse x, same but a small difference. We can either write as like this, real open interval minus 1 comma 1, that is real minus, that is, it's not r, that is not the range, it's the domain is all the real numbers except minus 1 and 1, okay? And the range will be closed interval minus pi by 2 comma pi by 2 minus set 0. Okay, here cosec inverse x can also have the same as this one. Domain can also be the same as this one or this. Okay, Just note it down, guys. Okay, now let us start with the properties of inverse trigonometric functions. So after discussing the properties, the chapter is over, because if we know all these things, we can solve any questions for the chapter inverse trigonometric functions. Properties. So the first property is sine inverse x is equal to cosec inverse 1 by x, and vice versa. That is, cosec inverse x is also equal to sine inverse 1 by x. Okay, the next one is for cos. What's the reciprocal of cos? Sec, right? So it will be, the logic will be like this: cos inverse x is equal to sec inverse of 1 by x. So same goes for sec inverse x is equal to cos inverse 1 by x. Okay, the next one is for tan and cot. That is, tan inverse x is equal to cot inverse 1 by x. So it will, the vice versa. That is, cot inverse x will also be equal to tan inverse 1 by x. Now we need to know some few formulas, important formulas. One is sine inverse x plus cos inverse x equal to pi by 2. Second one is tan inverse x plus cot inverse x will also be equal to pi by 2. Okay. Next formula, sec inverse x plus cosec inverse x will also be equal to pi by 2. So these three are very important formulas. Okay. Very, very, very important, I would say. Okay. Please go through this, because in questions we need to use these properties or so-called identities. Okay, now let us move on to the next set of formulas. Sine inverse x plus of minus sine inverse y. What will it be? Sine inverse x root of 1 minus y square plus of minus y root of 1 minus x square. Okay, simple formula, that is sine inverse x plus of minus sine inverse y equal to sine inverse in bracket x root of 1 minus y square plus of minus y root of 1 minus x square. The next formula is cos inverse x plus of minus cos inverse y, which will be equal to cos inverse xy. Here I have mentioned plus of minus, but here it will be like this: minus plus root of 1 minus x square into root of 1 minus y square. Okay. Next one is for tan and cot, right? Tan inverse x plus or minus tan inverse y equal to tan inverse x plus or minus y divided by 1 minus plus xy. Okay. The next formula that we need to know is which? For 2 tan inverse x. 2 tan inverse x equal to, it has three formulas in terms of sine, in terms of cos, and in terms of tan. So for in terms of sine, it's given like the sine inverse 2x by 1 plus x square. Okay. In terms of cos, it will be like this: cos inverse 1 minus x square by 1 plus x square. Then in terms of tan, it will be by tan inverse, same as sine, but there will be a sign difference here. That is tan inverse 2x by 1 minus x square. Okay. Similarly, we need to know about sine 2 sine inverse x, 2 cos inverse x and all. Okay. So for 2 sine inverse x, formula is sine inverse 2x into root of 1 minus x square. For 2 cos inverse x, actually there are two formulas. One in terms of sine inverse and one in terms of cos inverse. When it comes to sine inverse, it will be like this: sine inverse 1 minus 2x square. This is 1. And when it comes to cos inverse, it will be like this: cos inverse 2x square minus 1. Okay. The next is based on 3 sine inverse x. So don't get scared of all these formulas. All these formulas are like very basic formulas because you have learned a chapter called trigonometry in class 11, right? So if you can crack that chapter, it's very easy because that chapter there are a lot of formulas to learn. But when it comes here, only simple formulas like these to learn, because if you know these formulas, you can crack any question. For sine inverse 3 sine inverse x, the formula is like this: sine inverse 3x minus 4x cubed. Okay. Similarly, for 3 cos inverse x, the formula is like this: cos inverse 4x minus 3x cubed. That's, we are just interchanging, swapping. Okay. For 3 tan inverse x, formula will be like this: tan inverse 3x minus x cube divided by 1 minus 3x square. Okay. Now we need to know a big formula based on tan x. Suppose assume we have three angles x, y, and z. Okay. So tan inverse x plus tan inverse y plus tan inverse z equal to tan inverse x plus y plus z minus xyz divided by 1 minus xy plus yz plus xz. Simple, right? That is addition of all these angles minus product of all these angles by 1 minus 2 times multiplication of all these angles. So x plus y plus z minus xyz by 1 minus xy plus yz plus xz. Right. Now we need to know a small formulas. Okay. That is, you can give us a note. Okay. Just excuse me for 1 second. Let me drink some water. Okay, I'm back. Some more small formulas to discuss. Okay. First one is sine inverse of minus x be minus sine inverse x. Same goes for tan, not cos, tan. Okay. Tan inverse of minus x equal to minus tan inverse x. And this possibility also possible for one more, which is cosec, because why? Cosec is reciprocal of sine, right? So cosec inverse of minus x equal to minus cosec inverse x. Rest 4 we have to write in terms of pi minus. That is for cos, its reciprocal, and for cot. That is cos inverse of minus x equal to pi minus cos inverse x. Cot inverse of minus x is equal to pi minus cot inverse x. Last one, sec inverse of minus x equal to pi minus sec inverse x. So all these formulas, if you know, the chapter inverse trigonometric functions is complete. Okay, it's a very simple chapter. Okay, now let us do some questions for this chapter. This question has been asked in AATC for 10 times. For the past 10 years, it has been asking continuously in different shifts. Question is, if sec inverse x equal to cosec inverse y, then cos inverse 1 by x plus cos inverse 1 by y is. It's a very simple question. No need to use the formula for cos inverse x and cos inverse y. Look at the given data. From the given data, try to derive something and use that derivation or something, or create a new formula, create a new logic, apply this question. I'll just give 2 minutes to figure it out. If there's no response, I'll continue with the answer. Okay, if you want the options, I'll also give the options. Option A is pi. Option B is pi by 4. Option C is minus pi by 2. Option D is pi by 2. It's a very simple question, guys. Okay, I'll just show. So this question, this is the given data. Okay. So whenever questions like these are given, from the given data, try to resolve something. We know that sec inverse x is equal to cosec inverse y. So we don't have an identity for like when it comes to 1 by x and all. So our only one possibility is that we have to comprise a relation between this 1 by x and 1 by y. What is this? Okay, sec inverse x. We have studied that sec inverse x equal to cos inverse 1 by x, right? So we can write the LHS as cos inverse 1 by x, right? Equal to, what is cosec inverse y? Sin inverse 1 by y. I think we got the answer. That is, we just apply this concept here. Okay, that is, in terms of cos inverse 1 by x, we can give sin inverse 1 by y plus cos inverse 1 by y. So as per the identity, what's the answer? Pi by 2. See, simple question. We can resolve within 10 seconds. So the answer is D, pi by 2. AITC, sure question. Okay, I hope you all wrote the answer. Let us go to the next question. Okay, next question is quite an easy one. Sin inverse 3 by 5 plus tan inverse 1 by 7. This question we can apply the concept of Pythagoras theorem. Okay, when it comes to sin inverse, if this is theta, what is sine? Opposite by hypotenuse, right? 3, 5, right? So if this is 3, this is 5, this will be 4, right? So this in terms of tan, how can we write? Tan inverse 3 by 4, right? Yeah. So we can just add tan inverse 3 by 4 plus tan inverse 1 by x. What is tan inverse x plus tan inverse y? Tan inverse x plus y by 1 minus xy, right? That is tan inverse x plus y 3 by 4 plus 1 by z 1 by 7 by 1 minus 3 by 4 into 1 by 7. Okay. So we'll get the answer like around 1. So what is tan inverse 1? Pi by 4. So the answer will be pi by 4. Okay. I hope you guys understood this concept. Let us go to the next question. Next question is, if 2 tan inverse x equal to, sorry, there's a small correction. Okay, the question is like this. 2 tan inverse cos x equal to tan inverse 2 cosec x. Then what is x? Simple question. We have learned that 2 tan inverse x in terms of tan inverse x is tan inverse 2x by 1 plus x square, right? So we can write like this: tan inverse cos x by 1 plus cos x square or 1 minus x square. When it comes to sine, it's 1 plus, and I have told when it comes to tan, it will become 1 minus, right? Exactly. 1 minus cos square x equal to tan inverse. What is 2 cosec x? Isn't it same as 2 by sin x? So cancel these things. Oh, that's just quite simple. We know that sin square x plus cos square x equal to 1. So this can be written as, this term can be written as like this: cos x by sin square x equal to 2 by sin x. Cancel sin x and the square. Yeah, there is one thing you guys have forgot. Like, what is 2 tan inverse x? It's tan inverse 2x by 1 minus x square. But here I have wrote only cos x. So there's a 2 here actually. So 2 here. So 2 and 2 cancelled. You understand how this 2 came? That is tan inverse 2 tan inverse x equal to tan inverse 2x by 1 minus x square. So 2x. Here x is cos x. Okay. So this is cancelled. This one cancelled. So what is it? Cot x is equal to 1. X is equal to pi by 4. Cot inverse 1. Just pi by 4. See? Simple question. Note it down. Okay. Next question. If sin inverse x minus cos inverse x equal to pi by 6, then what is the value of x? Simple question. We have sin inverse x minus cos inverse x is equal to pi by 6. We have an identity called like this: sin inverse x plus cos inverse x equal to pi by 2, right? Take this as equation number 1. Take this as equation number 2. We are just adding equation 1 plus equation 2. What happens? This and this can be get cancelled. And what is like pi by 6 plus pi by 2? Pi by 6 plus pi by 2. You can just take the LCM and solve it. By 6, 6 by 6, 1 pi plus 2, 3, 4 pi. Three pi plus 4 pi by 6. 4 pi by 6, 4 by 6, we can just cancel 2, 3. So it will be get like 2 sine inverse x equal to 2 pi by 3, right? Cancel off these 2. So what is x? X is equal to, if we push sine to the arches, we'll get like this. Sine pi by 3. What is pi by 3? If you forgot about the angle gradient, we can convert to degree as like this. Pi by 3 into 180 by pi. So cancel this. We'll get angle 60. So what is sine 60? Root 3 by 2. That's the answer. Okay. Okay. Just give a 1 minute break. Let us go to the next question. Next question is sec of tan inverse b plus a divided by b minus a minus tan inverse a by b. So when you see questions like this, don't need to be scared because it's quite easy. So here there's a hint in the question itself. The hint is we have to find a term from tan inverse b plus a by b minus a in which we can cancel out tan inverse a by b. That's why the main purpose of minus is given here. There's no need to expand. So let me do one thing. Let me figure out whether I can simplify this tan inverse b plus a by b minus a. Okay, let me write it down. Tan inverse b plus a by b minus a. Okay, internally I'm just dividing b on both numerator and denominator. That is, I'm just multiplying 1 by b on numerator and denominator. So it will be like this. Tan inverse 1 by b into b is 1. 1 by b into a is a by b. 1 by b into b is 1 divided by 1 minus 1 by b into a is a by b. So isn't this, assume there's into 1 here, we can say that this is equivalent to like this, tan inverse a plus tan inverse b, right? So here is tan inverse 1 plus tan inverse a by b. So when we go to the question, we can substitute that b plus a by b minus a with the help of this. That is, now the resultant would be like this. Sec of tan inverse 1 plus tan inverse a by b minus tan inverse a by b, right? Cancel this. What is tan inverse 1? Pi by 4. What is sec pi by 4? What sec 45? What is cos 45? Cos 45 is 1 by root 2. So what is sec 45? The reciprocal of cos, right? Answer is root 2. That is, we just need to know about sine, cos, and tan, because with the help of reciprocals, we can know cosec, sec, and cot. Okay, this was a good challenging question. Okay, next question is quite an easy question. If sine inverse x equal to pi by 5, then the value of cos inverse x. I'm not showing the answer for this question. It's very easy. We have the identity sine inverse x plus cos inverse x equal to pi by 2, right? We can just substitute this value here, right? Substitute that value, we'll just get sine inverse x. Sorry, I mean, we can substitute sine inverse x, the value of sine x there, so that we can get what? Cos inverse x, right? Okay. Okay. An important question. Cos inverse of cos 3 pi by 2. This is an important question because 90% of the students will be writing the answers as 3 pi by 2, right? But the answer is wrong. There's a reason. Okay. Because what is the range of cos inverse x? We have learned the range of cos inverse x is from 0 to pi. 3 pi by 2, 1.5 pi is outside this limit, right? So this is not possible. Okay. So instead of 3 pi by 2, we can write like this. Cos inverse of cos of pi plus pi by 2. Sin 3 pi by 2, that is 2 pi plus 3 pi by 2. Okay. Now we have to consider this. A S T C. Where is pi? This is pi. Here we are adding pi plus theta. So what is cos of pi plus theta? Here only tan is positive, rest all are negative. Minus cos theta. That is, it will be like this. Cos inverse of minus cos pi by 2. Okay. We have learned that cos inverse of minus x is pi minus cos inverse x. That is pi minus cos inverse x. Here what is x? X is cos pi by 2. That is cos inverse cos pi by 2. Right. So the answer will be like this. Pi minus pi by 2, it will be equal to pi by 2. This is a tricky question. Sure question for 80C exams. Okay, I think this much questions is enough for today's session we have, because we have almost covered all types of questions that can be asked in inverse trigonometric functions. So if you know all these formulas and are able to solve these type of questions, let any questions come for the exam, you can solve it very easily. Okay. So thank you guys for the support, and thank you and have a nice day.